All right, so we're diving into something pretty fascinating today.
Definitely.
It's this essay, Quantensensorik, Precision in Messung and Technology.
Okay.
And that is by Jorgo Schneppet.
Interesting.
It's all about quantum sensing, which is...
Oh, wow.
Yeah, it's incredible.
I've heard a little bit about this, but I'm really interested to hear more about it.
Yeah, so this is a field that is really kind of poised to change everything.
It really is.
Like how we do medicine, navigation.
Oh, that's a big claim.
All sorts of things.
And it all comes down to quantum mechanics.
Yeah.
That's always felt so theoretical to me.
Right.
But to think that we can actually use it to create groundbreaking technologies.
Yeah, it's like stepping into the future.
It really is.
So for our listener, maybe they're hearing about this for the first time.
Yeah.
What is quantum sensing?
So quantum sensing basically uses these principles of quantum mechanics to measure things incredibly precisely.
Okay.
I like to think about it this way.
Yeah.
Traditional sensors.
Right.
It's like using a ruler.
Okay.
But quantum sensors are using a microscope that can see individual atoms.
Oh, wow. That's a really good analogy.
Yeah.
So what makes them so much more precise than the tools that we're using right now?
Well, it really comes down to this idea of harnessing these two bizarre but powerful quantum phenomena.
Okay.
Superposition and entanglement.
Okay. Now we're talking. This is where it gets really interesting.
Absolutely.
So break those down for us.
Right. So imagine an atom being in two places at once.
Okay.
That's superposition.
What?
Yeah. And so quantum sensors use this to become incredibly sensitive to even the tiniest changes in their surroundings.
So it's like they're exploring all these different possibilities at the same time, which makes them like hypersensitive?
Yeah, exactly.
Wow.
And then there's entanglement.
Okay.
So now picture two particles that are linked together, even if they're miles apart.
Okay.
You measure one,
Right.
and you instantly know something about the other.
Yeah.
It's kind of spooky.
It's what?
Spooky action at a distance, right?
Yeah.
But this is what allows for unprecedented levels of precision in these measurements.
That's mind-boggling.
It really is.
But why do we even need this level of precision?
Well, think about it.
Yeah.
Our current sensors,
Right.
They're hitting their limits.
Okay.
They just don't have that sensitivity to measure those subtle changes that are becoming increasingly important in a lot of fields.
Okay.
So, for instance, in medicine,
Yeah.
imagine being able to detect the faintest magnetic signals from the brain
Right.
to diagnose neurological conditions way earlier and much more accurately.
Okay.
That's where quantum sensors can really step in.
Yeah, so we're moving beyond just seeing the forest, and now we're able to study individual leaves on the trees.
Exactly. That's where the real power of quantum sensing lies.
That's incredible.
It really is.
So what are the tools that are allowing us to tap into this quantum realm?
Okay.
Like what technologies are driving this revolution in sensing?
Yeah, great question. So there's a few key players here.
Right.
One of them is quantum dots.
What do you-
These tiny semiconductor crystals that are essentially acting like artificial atoms.
Artificial atoms.
Oh, I know, right?
It sounds like science fiction.
It really does, but they're really cool because they have these distinct energy levels, just like real atoms.
Right.
And they emit light in very specific ways.
Oh, wow.
Which makes them super useful for sensing.
Oh.
So, for instance, they can detect the presence of a single molecule
What?
by altering how they emit light.
Wow, so they're like these miniature lighthouses signaling changes in their environment
That's a great way to put it.
with incredible precision.
Absolutely.
It's amazing.
And then we've got atom interferometers.
Okay.
Now, this is really mind-blowing.
Right.
Imagine splitting an atom in two,
Okay.
sending the halves on different paths, and then recombining them to see how their journey has affected them.
Okay, now that's just mind-blowing.
Yeah.
Splitting an atom.
It really is a testament to how powerful quantum mechanics is.
Wow.
By analyzing how these atomic waves interfere with each other,
Okay.
we can measure things like gravity or rotation with just astonishing accuracy.
So it's like having these microscopic surveyors mapping out the subtle forces around them.
That's a great analogy. I like that.
That's incredible.
It really is.
So how do we manipulate something so small to gain like such profound insights?
It's really amazing.
Yeah.
What else do we have in our quantum toolbox?
Yeah.
Well, another crucial technology is superconducting quantum circuits.
Okay.
These are circuits that operate at ultra-low temperatures,
Oh.
where electrical resistance completely vanishes.
It's like a frictionless world for electricity.
Exactly. And this allows these circuits to detect even the tiniest magnetic fields,
Oh, wow.
revealing hidden details about materials or even the human brain.
It's crazy to think about that.
It is.
All of this sounds incredibly complex and like cutting edge.
Yeah.
But how is quantum sensing actually being applied in the real world?
Okay, yeah.
Where are we seeing its impact today?
So one area where it's really making waves is navigation.
Go ahead.
So I got GPS.
Okay.
Quantum compasses are now using atom interferometers and super accurate atomic clocks to guide submarines and planes in locations where those GPS signals just can't reach.
So we're talking about a whole new level of navigational independence and security?
Absolutely.
Wow.
But it goes far beyond just that.
Okay.
Quantum sensing has this incredible potential to revolutionize healthcare.
In what way?
So superconducting magnetometers, like squeeides, can see the brain's activity in unprecedented detail.
Wow.
And that could lead to earlier and more accurate diagnoses of neurological conditions like Alzheimer's or Parkinson's disease.
It's incredible to think that we might one day be able to see the subtle workings of the brain with such clarity.
It is. It's truly groundbreaking. And that's just the tip of the iceberg.
Really?
Oh, yeah. Imagine quantum sensors being used as environmental watchdogs.
Oh.
They could sniff out CO2 emissions and temperature fluctuations with pinpoint accuracy.
So it's like our eyes and ears on the environment.
Exactly.
Helping us understand and address climate change more effectively.
Absolutely.
Wow.
And these are just a few examples.
There's more.
Oh, there's so much more.
Okay.
Quantum sensing is poised to revolutionize industries from aerospace to pharmaceuticals.
Wow.
It's already being used for quality control and material analysis, ensuring that products are safer and more reliable.
Wow. So how does that work?
Well, for example, imagine using quantum sensors to monitor the delicate process of protein folding in real time.
Okay.
That would ensure the effectiveness of new drug therapies.
Wow, that's incredible.
It is.
So it's amazing to see how this seemingly abstract field of quantum mechanics is finding such practical and impactful applications.
It really is. And this is just the beginning.
The beginning?
Oh, yeah. The future of quantum sensing. It's just brimming with possibilities.
So speaking of the future,
where
do you see this technology heading in the next 20 years?
Okay.
What kind of world will quantum sensing create?
I think it's going to be incredible, so let me tell you about it. The potential is just vast.
Okay.
One area that I'm particularly excited about is the miniaturization of these quantum sensors.
Okay, so instead of these large, complex instruments we see in labs, we could have quantum sensors embedded in everyday devices.
Exactly.
Yeah.
Imagine like having them in our smartphones, monitoring our health in real time, detecting minute changes in our bodies that could like signal the early stages of a disease.
So it's like having a personal health guardian right on your wrist.
Precisely.
Wow.
And the applications extend far beyond just personal health.
Okay, like what?
Well, think about self-driving cars navigating with unprecedented accuracy using those quantum compasses. Or drones that are equipped with quantum sensors that are mapping out underground infrastructure with pinpoint precision.
It sounds like we're on the cusp of a world where quantum sensing is seamlessly integrated into our lives.
I think so, and that's not even scratching the surface.
Really?
Oh, yeah.
There's more.
As the technology matures, we can expect even more radical applications.
Like what? What are we talking?
Imagine using quantum sensors to detect dark matter.
Oh, yeah.
That elusive substance that makes up a significant portion of the universe.
Right.
But it remains invisible to our current instruments.
So we could be on the verge of unlocking some of the universe's greatest mysteries using these quantum tools.
It's a very tantalizing possibility.
Wow.
And while there are still challenges to overcome,
sure,
in terms of scalability and cost, the progress we've seen in recent years is truly remarkable.
That's really exciting.
It is.
It makes you wonder where we'll be in another 20 years.
I know. The future of quantum sensing is bright.
It really is.
Definitely.
Well, this has been an incredible journey diving into quantensensorik, precision in messung and technology by Gyroscopes.
I agree.
It's so fascinating to see how this strange world of quantum mechanics is leading to such practical and potentially world-changing technologies.
It's amazing. It's a testament to human ingenuity.
Absolutely.
And our endless quest to understand and harness the forces of nature.
I love that.
Yeah.
So for our listener,
yeah,
if you had a quantum sensor in your pocket right now,
right,
what would you use it for?
I don't even know. The possibilities are truly endless.
They really are.
Yeah.
Thanks for joining us on this exploration of this incredible world of quantum sensing.
Absolutely. It's been a pleasure. It's going to be incredible.
Yeah, it really feels like we're on the verge of a technological leap.
Yeah.
Like as significant as the invention of the computer.
I agree. The potential is truly vast.
Yeah.
One area that's particularly exciting is the miniaturization of these quantum sensors.
Okay, so instead of these large, complex instruments that we see in labs,
right,
we could have quantum sensors embedded in everyday devices.
Exactly.
Oh.
We could have them in our smartphones, monitoring our health in real time.
Okay.
Detecting minute changes in our bodies that could signal the early stages of a disease.
So it's like having a personal health guardian.
Precisely.
Right on your wrist.
Right. And the applications extend far beyond personal health.
Oh, yeah. Like what?
Think about self-driving cars navigating with unprecedented accuracy using quantum compasses.
Okay.
Or drones equipped with quantum sensors mapping out underground infrastructure.
Wow.
With pinpoint precision.
It sounds like we're on the cusp of a world where quantum sensing is seamlessly integrated into our lives.
I think so, and that's not even scratching the surface.
Really? There's more.
As the technology matures, we can expect even more radical applications.
Like what are we talking?
Imagine using quantum sensors to detect dark matter.
Okay.
That elusive substance that makes up a significant portion of the universe.
Right.
But remains invisible to our current instruments.
So we could be on the verge of unlocking some of the universe's greatest mysteries.
Yeah.
Using these quantum tools.
It's a tantalizing possibility.
Wow. And while there are still challenges to overcome,
of course,
in terms of scalability and cost,
right,
the progress we've seen in recent years is truly remarkable.
It really is.
The future of quantum sensing is bright.
It is, definitely.
Well, this deep dive into quantensensorik, precision in messung technology by Gyroscopes has been incredible.
It has.
It's fascinating to see how this strange world of quantum mechanics is leading to such practical and potentially world-changing technologies.
It's a testament to human ingenuity.
Absolutely.
And our endless quest to understand and harness the forces of nature.
If you had a quantum sensor in your pocket right now, what would you use it for?
The possibilities are truly endless.
Thanks for joining us on this exploration of the incredible world of quantum sensing.